So we are dealing with problem 2.10 in the Irodov solving series, and the problem is stating a smooth vertical tube having two different sections is open from both ends and equipped with two pistons of different areas. Each piston slides within a respective tube section. 1 mole of ideal gas is enclosed between the pistons, tied with a non-stretchable thread. The cross-sectional area of the upper piston is 10 cm square greater than that of the lower one. The combined mass of the two pistons is equal to 5 kg and the outside air pressure is 1 atmosphere. By how many Kelvin must the gas between the piston be heated to shift the piston through 5 cm? So if we consider the situation shown in the diagram, so over here we have 1 mole of an ideal gas which is enclosed between these two pistons, where one piston is of larger cross sectional area. So we are considering this cross section area as S1 and the another cross section area as S2. And over here the problem is stating that the cross sectional area of the upper piston is 10 cm square greater. So we can say S1 minus S2 is 10 cm square. The upper piston is having greater area by 10 cm square. So over here if I consider M1 as the mass of this piston, that is M1G, and M2 as the mass of this system, that is M2G, then we can say that the combined mass of the system M1 plus M2 times G will turn out to be 5 kg, that is they will contribute 5 G or 50 Newton force in the downward direction. Now since in the scenario given to us it is mentioned that outside pressure is equal to atmospheric pressure, so which we are writing as P0. So over here if we identify the forces, then the forces can be understood as, due to atmospheric pressure, a force P0 multiplied by S1 will be acting on the upper piston. The weight M1G will be in the downward direction. There will be a tension in the string or the thread. The two will be equal and opposite in nature as accordance to the Newton's third law of motion. Over here the atmospheric pressure will exert a force P0 times S2. The weight of the piston M2G is in the downward direction. And over here we can understand this situation like this. And now what is done? The gas inside this piston is heated. So due to heating effect, the gas will acquire some energy and it will try to occupy more volume. And the question is stating that due to the heat given to the system, the piston shift by a distance of 5 cm. So we can say that the shift in this distance is in the upward direction, or I can say that the upper piston will move by 5 cm in the upper direction and the lower piston will move by 5 cm in the upper direction, because the string connecting them is non-stretchable in nature. So now if we write the equations pertaining to this, so one more force we have missed out over here. One more force which we can consider is the force which the gas is going to exert. So if the gas is having a pressure P, then this gas will exert a force PS1 on the upper piston in this direction, and the same gas is going to exert a force PS2 on the lower piston in this direction. So now if we write force equation for each piston, then we can say that for the total mass of the system, we can say that for upper piston, so we are writing for upper piston. Let us consider for each piston, then we will write for the entire system. So for upper piston, the forces which is acting in the upward direction, so it is only PS1 which is acting in the upward direction. The rest of the forces, so we can say that the rest of the forces are trying to pull it down. So we can say that PS1 is equal to M1G, which is in the downward direction, P0 S1 which is in the downward direction, tensional force T, which is also pulling the piston in the downward direction. And now if we write for lower piston, so for lower piston, we say that the forces in the upward direction are T, then we have another force P0 S2, and in the downward direction we have a force PS2 and weight M2G, which is in the downward direction. So this is expression 1 that we have, and this is expression 2 that we have. So if we equate the tensional force on either side, then on equating the tensional force on either side, we can get an expression. So we equate tensional force, so I am writing from equation 1 and 2, from equation 1 and 2, then we can write over here that tensional force can be written as PS1 minus M1G minus P0 S1, and this is equal to PS2 plus M2G minus P0 S2. So this is the expression which we can write. Now again, if we consider the fact that we are given that the difference in area S1 minus S2 is 10 centimeter square, and this variable or the parameter which we mention as delta S is given in the problem. So if we rewrite this expression in this sense, then we can say that P S1 minus S2 minus P0 S1 and then P0 S2, so we write it as P0 S1 minus S2 is equal to M1 plus M2G. So from here we have simplified this expression that S1 minus S2 can be written as delta S. So over here we can write that P times delta S minus P0 times delta S is equal to total mass of the system, which is given to us as 5 kg, times G. And over here we can say that if we write an expression for P, or pressure of the gas which is inside the piston arrangement, then we can say M total G by delta S taken common, and plus P0, and this parameter is going to be a constant because over here G is constant, total mass of the piston is constant, delta S is constant, and P0 is constant. So over here we can say that the pressure inside the system or inside the chamber has turned out to be constant. So over here we have established an interesting conclusion that pressure inside this chamber is going to remain constant, and we have 1 mole of a gas. So if we have 1 mole of a gas and pressure is constant and we are having N equal to 1 mole, so we can definitely write that volume is proportional to temperature. So therefore we can write that the change in volume which the system is undergoing is equal to L times of delta S. So as the question has suggested that the piston rises by 5 centimeter. So on being heated, the above piston is going to rise by 5 centimeter, thereby increasing its volume by S1 into L, and this will rise up by S2 into L. So since S1 into L will contribute to greater volume compared to S2 into L, which will decrease its volume, so we can say that the change in volume as the piston rises is going to be S1L minus S2L, that is S1 minus S2 times L. So over here S1 minus S2 is treated as delta S into L. So this is going to be the change in volume. So this change in volume, which is equal to L into delta S. So over here we can write, hence from ideal gas equation, hence from ideal gas equation we can write PV equals RT for 1 mole, and PdV or P delta V plus V delta P is equal to R delta T, and since delta P is equal to 0, since pressure is constant, so therefore we write that the change in temperature delta T is equal to P times of delta V by R. So over here, if we put this value of P over here and then multiply it by delta V by R, we will get the change in temperature. So hence we can say that the change in temperature delta T is equal to, so P naught plus delta S or P naught delta S. So we are substituting the value of P over here, P which we have obtained in this way. So we are writing M total G by delta S plus P naught times delta V. So delta V we are writing it as L delta S upon R. So this is going to be the expression for the change in temperature. So if we multiply this by delta S term, so we are going to land at an answer P naught times delta S plus mg L by R. Now if we substitute the value which is suggesting over here that delta S being equal to, this is M total, so delta S being equal to 10 centimeter square, the total mass which we are mentioning over here as M1 plus M2 is equal to 5g or 50 Newton, and P naught being atmospheric pressure, L given to us as 5 centimeter. So over here on substituting the values we come to a conclusion that the change in temperature is equal to 0.9 Kelvin. So this is the final answer for this particular problem. So let us re-revise the concept which we have used in this problem. The first thing which we did was identify this entire system, and now we have atmospheric pressure which is acting in play, that is P naught, which is going to exert a pressure on the upper piston, the weight of the upper piston in the downward direction, followed by the pressure which the gas is going to exert on the upper piston and tensional force. Then we write force equation for individual piston, and on solving for pressure of the gas, we land at an interesting conclusion that pressure is equal to constant inside the chamber when it rises or falls, and hence we can say that delta P or change in pressure is 0, or the process is isobaric in nature. For isobaric process we can write that V proportional to T or change in temperature, and then we use the ideal gas equation for 1 mole of the gas to calculate the change in temperature and land at this interesting conclusion or answer which is equal to 0.9 Kelvin. So this was problem number 2.10 in I.E Irodov solving series.